Bismillahirrahmanirrahim. Assalamu alaikum. Today in this video we are going to learn about the relation between the coefficients of the quadratic equation of the form ax square plus bx plus c and the roots of this quadratic equation. In the previous video we observed the equation x square plus bx plus c equals 0, and we observed that if alpha and beta are this are the roots of this quadratic equation, we have the sum of roots equals to negative coefficient of x, and we have the product of roots equals to the constant of the quadratic equation. Now how can we express the sum and the product of the roots in terms of the coefficients and the constant of the quadratic equation in the form ax square plus bx plus c? Now let us see. Ax square plus bx plus c equals 0. We can simplify this equation by dividing both sides by a. In short, I would say that we are dividing all the terms of this equation by a. So in this way we would be reducing the equation. Okay, let me simplify it in a simple way. A multiplied by x square plus b upon a x plus c upon a equals 0. Now since we are considering that a is a constant, a has a specific value, a is not a variable, so we would divide a from both sides and we would obtain x square plus b upon a x plus c upon a equals 0. Now we have the sum of roots equal to the negative coefficient of x. This form of the equation and this form of the equation are exactly the same. The rule which applies over here, it would also apply in this form. So we have the sum of roots equals to negative coefficient of x, that is in this case minus b upon a. And now the product of roots, obviously it's equal to the constant, that is c upon a. Now in order to prove it, I would be solving a quadratic equation and showing you that the sum of the roots and the product of the roots are exactly equals to minus b upon a and c upon a. Now let us solve a quadratic equation. We have 2x square minus x minus 1 equals 0. Now we would be breaking the middle term into minus 2x plus x minus 1 equals 0. 2x multiplied by x minus 1 plus x minus 1 equals 0. So now we have 2x plus 1 and x minus 1 equals 0. Therefore we have the quadratic. I would be writing the quadratic equation again on the next page. 2x square minus x minus 1 equals 0. Our previous step was 2x plus 1 multiplied by x minus 1 equals 0. So we would obtain x is equals to minus 1 over 2 or x equals 1. So we have the two roots of this quadratic equation, which are equals to minus 1 upon 2 and 1. Now let us check that whether they match the sum of roots or not. So the sum of roots would be equal to the negative coefficient of x over the coefficient of x square. In short, I would be simplifying it by writing it in the margin. Sum of roots equals minus b over a. Product of roots equal c over a. Now let me make it clear. I am cutting it in order to simplify the solution. I would be simplifying it in a more clear way. So the sum of roots is equals to minus b over a. So we have b equals to minus 1 and a equals 2. So the sum of roots that are minus 1 over 2 plus 1, they would go in the left hand side, and in the right hand side we would have minus 1 over 2. So 1 over 2 is equals to 1 over 2, left hand side equals to right hand side. Now towards calculating the product of roots. Product of roots is equal to c over a. Now regarding this equation, we have minus 1 over 2 into 1 on the left hand side, because we have these two roots, so we would take their product in the left hand side, and in the right hand side we would have minus 1 minus c over a, which means c is equals to minus 1 and a is equal to 2. So we would have minus 1 over 2. Minus 1 over 2 is equals to minus 1 over 2. We again have the left hand side equals to the right hand side. So what's the difference between the previous lecture and this lecture? What's the difference? What's the difference between these forms? There is no difference in concept, but there is obviously a difference between the formula. For the equation in the form x squared plus bx plus c equals 0, the sum of roots is equals to minus b. Product of roots is equals to c. Now in the form ax squared plus bx plus c, the concept is the same. We would reduce the equation by dividing both sides by a, but we would obtain different expressions for the sum of roots and the product of roots due to a different form of the equation. Sum of roots is equals to minus b over a, and the product of roots is equals to c over a. Okay, for your, if we pay attention towards this equation, if we input 1 instead of a, 1 in place, if we substitute 1 in place of a, we would obtain the same results as we have obtained over here. For example, I would be substituting 1 in place of a. So we have x squared plus bx plus c equals 0. I am substituting in this equation ax squared plus bx plus c equals 0. We have sum of roots equals to minus b over 1 is equals to minus b. That's the same as the first results we have worked out, and the product of roots would be equals to c over 1, that is equals to c. So these both results are the same, and so it can be deduced that these both concepts are same in principle. Now we would be solving one of the questions in order to gain more grip over this subject. We have question number 2 of this topic. Question number 2 states that alpha and beta are the roots of the quadratic equation two x squared plus 3x plus 10 equals 0. calculate the value of alpha square plus beta square. Then we have to calculate the value of 1 upon alpha plus 1 upon beta. Now we will move a step further and calculate the sum of the reciprocals of the roots. Now moving towards the solution, we have the quadratic equation. I would write it again: 2x squared plus 3x plus 10 equals 0. And in part 1 we have to calculate alpha square plus beta square. We would use the same method. We would calculate alpha plus beta, but now that would be equals to minus b upon a. That means minus b upon a. And the product of roots would be equals to c upon a. That is 10 over 2 is equals to 5. Now squaring the sum of both roots, we would obtain a alpha square plus 2 alpha beta plus beta square. Now in the same way as in the previous lecture, we would calculate the sum of the squares of the roots. We have alpha square plus beta square is equals to alpha plus beta whole square minus 2 alpha beta. That would be equals to minus 3 upon 2 whole square minus 5 multiplied by 2. That would be equals to 1.5 square, that is equals to 2.25 minus 10. Now that is finally equals to minus 7.75. That is equals to minus 7.75. So it can be observed, as we observed in the previous video, the sum of the squares of root is again turning negative. That means that the value of alpha and the value of beta is complex. Why both of them are complex? It can be said that even one of them can also be complex, but since the coefficients of this quadratic equation are real, it always follows that if the roots are present, if the complex roots are present, they always occur in pairs. There can be 2 complex roots, there can be 4 complex roots, but there cannot be 1 complex root, there cannot be 3 complex roots. The complex roots always come in conjugate pairs when the equation have real coefficients and the real constants. Now towards the second part. The second part demands that we should calculate 1 upon alpha plus 1 upon beta. There is a simple algebra to perform. We have to take the LCM of both fractions. So we would obtain alpha plus beta upon alpha beta. Now the rest of the cell step is simple. We would obtain negative 3 over 2 divided by 10 divided by 5 divided by 5. Now that's a common mistake the student perform. The students take the constant, they take the product of the roots to be 10, as I had taken here by mistake. But the students commonly perform this mistake. They take the coefficient, they take this product of roots to be exactly equals to 10, but it's not equals to 10, it's 10 upon 2. That's the common mistake the student perform in their examinations. So we have, as a result of this, minus 3 over 10, that is equals to minus 0.3. Now imagine that we have complex roots. We would be taking out the roots, we would be calculating the roots in the form of iotas, and then we would be taking the reciprocals and then we would be adding them. It's better that we would use the Vitas theorem, or we would use the relation between the roots of the quadratic equation and the coefficients in order to calculate the sum of the reciprocal of the roots. Now that marks the end of the video. I hope that you would have completely appreciated the relation between the roots of the quadratic function and its coefficients. Thank you very much. In the next video, I would be solving more questions regarding the relation between the roots of the quadratic equation and its coefficients, and we would be performing similar algebraic operations. We would be studying it in an advanced way. We would be, for example, we would be now calculating 1 upon alpha square plus 1 upon beta square. There's also a specific algorithm in order to calculate this. There is a specific method to calculate this, and we would also be calculating alpha cube plus beta cube, and we would also be calculating alpha square beta plus alpha beta square. There's also a method to calculate this. So till now, Allah Hafiz, and we would meet soon in the next video.